Environmental chemistry. The meaning of this is it deals with the study of some of the social, economical, biological, physical and chemical interrelations with the surroundings. It relates with environment and what is the role of this chemistry in this environment we are going to discuss in this topic. It is more of general awareness to the students, and it gives an idea about the environment also, and related questions also we'll discuss in this topic. Let's see now what are all the things which are there in the environment, and in this what are the elements present in the environment, what are the contents in the environment. We will see what are the segments present in the environment. We'll discuss here. We can have in the environment, you can have atmospheric zone, biospheric zone, hydrospheric zone and lithospheric zone. And now majorly we'll discuss about atmosphere here. If you see this atmosphere, what is this atmosphere here? Atmosphere is a protective blanket of the gases surrounding the earth. It's a protective blanket, gases surrounding the earth. In this is what you can see. Atmosphere is the protective blanket of gases surrounding the earth. So this protective blanket, this is what you can see. This is what atmosphere over here. This is considered to be atmosphere. This is what. So this blanket of gases will be surrounding the earth's surface here. About this part, what is actually happening over here, in this we'll have some discussion in this related with this concept. So this atmospheric gases saves the life from the hostile environment in the outer space. From the outer space the gases will enter. The atmospheric gases will be protecting. Atmospheric gases will be protecting this to some extent this earth surface, and if that cannot protect the earth surface, then pollution will be begin. It causes some drastic disasters here. So this saves life from the hostile environmental in the outer space. Now actually this segment is commonly referred to as air. This is what you can say, this whole thing you can say atmospheric air. This is what atmospheric gases are, I can say this is air. In this you can say it consists of 4 spheres extending up to 500 kilometers. This atmospheric gases or air consists of, it is having 4 segments extending from 0 kilometer to 500 kilometer. 0 kilometer to 500 kilometer. What are all these segments? How they are being distributed? We'll have a discussion now. Then principal layers in the atmosphere we'll discuss, that is from 0 to 500 kilometers. Let us see the division like this. This atmospheric gases now 4 segments from 0 to 500 kilometers. In this we can see 0 to 10 kilometers. This is called troposphere. This is called troposphere. Then coming to 10 to 50th kilometer, this is stratosphere. Coming to mesosphere, third one, this is having 50 to 90 kilometers. This is mesosphere, 50 to 90 kilometers. Then coming to thermosphere, this is from 90 to 500 kilometer. This is thermosphere. This is from 90 to 500 kilometers. Right from 0 to 500 kilometer is the principles of the principal layers in the atmosphere divided into 4 segments. That is, you can see troposphere, that is 0 to 10 kilometers, stratosphere 10 to 50 kilometers, mesosphere 50 to 90 kilometers, and thermosphere 90 to 500 kilometer. What are all there in this troposphere? What is actually going on in this sphere? We'll have a detailed point. And about to this, if at all you have some sphere, that is, we can call it as exosphere, that is above 500 kilometer. But actually our point of discussion up to this only, above 500 kilometer, we can have exosphere. We can have exosphere over here. Coming to atmosphere, you can have this atmosphere consists of all these segments here. Now, troposphere 0 to 10 kilometers, it consists of atmospheric gases. It protects the life on the it protects the life on the earth. Because these atmospheric gases will protect the life. Okay, then coming to stratosphere, this is 10 to 50 kilometers. Ozone layer is present over here. 50 to 90 kilometers, here sound waves do not propagate. And 90 to 500 kilometer thermosphere, here ionization of gases occurs. In detail, I'll discuss about this. Let me concentrate on each and every layer over here. Look at this. Coming to the, okay, in detail discussions. Let us see now. Troposphere, the range 0 to 10 kilometers already discussed. Temperature in this particularly 15 to 56 here. This is a range of temperature. In this, main constituents are given as nitrogen gas, oxygen gas, then carbon dioxide gas, water vapor. These are the main constituents in the troposphere. N2, O2, CO2, H2O. N2, O2, CO2 and H2O are the main constituents in this troposphere. Stratosphere, it is ranging from 10 to 58 kilometers, and you can have a temperature range from minus 56 to 2, and the main constituents in this stratosphere are mainly ozone and O2. Here ozone and O2. These are the stratospheric gases over here. Coming to mesosphere, it is ranging from 50 to 90 kilometers, and the temperature ranges from 2 to 92 here the temperature region. And in this, the main constituents in the mesosphere are N2 gas and O2 plus gaseous ion. Okay, and coming to thermosphere, in this thermosphere, the range from 90 to 500 kilometer, and in this the temperature ranges from 92 to 1200. Here high temperature is maintained over here. The main constituents in this are O2, O2 plus and NO plus. These are the gases and their ions. O2 is a gas, O2 plus is ion, NO plus is the nitric oxide gas. So these are the gaseous and gaseous ions present in the thermosphere. This is what you can see main constituents in the atmosphere. Now, coming to some more detailed points about troposphere. As already discussed about this troposphere, it is having mainly N2, O2, CO2, water vapor. It is the lowest layer on the Earth's surface, that is from 0 to 10 kilometers. We are all surviving in this layer only 0 to 10 kilometers, and in the Earth's atmosphere, it extends to an average height up to maximum 10 kilometers, maximum of 10 kilometers from the surface of the Earth. Now, it consists of the following, following regions, I can say this. One is hydrosphere, that is hydro means water, water contents, water body. It is having lithosphere, litho means land, soil related. So litho means land, hydro means water. So litho plus hydro together, land and water together is present in this lower layer, that is 0 to 10 kilometers layer. So it is the ranging here. Then together life exists because of land and water, that is litho and hydro, therefore it is called biosphere. So we are all living in this 0 to 10 kilometer, that is in the biosphere. Biosphere is a part of 0 to 10 kilometers only, that is comes under troposphere here. Then about troposphere, what is its actually major role played? This troposphere plays very important role here because this N2O2 CO2 and water vapor, carbon dioxide up to certain minimum level is useful to us. Beyond that, it causes some greenhouse, it will become a greenhouse gas, it will cause global warming. So up to certain level, it protects the heat radiations which are coming from the sunlight, which will protect the life, or I can say that it will maintain the heat balance rather. So the mainly heat balance is done by this CO2 to certain minimum extent. Beyond that, it causes the blanketing effect and causes pollution. That we will discuss in the later. Coming to hydrosphere, already we have discussed lithosphere, already we have discussed about lithosphere, it's related to land, and coming to hydrosphere, it is related to water contents, and it includes all the types of water bodies, ocean water, sea water, river water, all the kinds of water are comes under hydrosphere only. All the land related is it's an outer mantle of the solid earth consists of minerals and soils, you can call it as a lithosphere. Combination of lithosphere and hydrosphere is nothing but a biosphere. It includes all living species including human beings, okay, even plants and animals, everything comes under this biosphere only. Okay, all these are there in 0 to 10 kilometers where the life has been existing here. This is what we are there, 0 to 10 kilometers, so that is what troposphere here. Coming to related one or two few questions on this first concept which we have discussed now. Okay, suppose if an object is there at a height of 5 kilometers from the surface of the earth, in which part of the atmosphere that object is being located? So that object can be 0 to 10 kilometers, because the question itself I have said that an object is there up to 5 kilometers. That means to which part, if I give options troposphere, stratosphere, mesosphere, thermosphere, you can give an answer. Obviously it will be there in which sphere, which region, you can give an answer as troposphere. So we can go for option as troposphere, stratosphere, mesosphere, thermosphere. So we can go for option as troposphere over here. That is because it is obviously there into 0 to 5th kilometer only. Okay, coming to another conceptual question related to the same concepts here. Let us see the basic questions here. In which part of the atmosphere, suppose ozone layer is present? As already I have discussed up to this, it is having this one. In the stratosphere, already I have discussed here, ozone is present. Ozone is present in the stratosphere. In which part of the atmosphere ozone layer is present? If the question is given as again 4 options, troposphere, stratosphere, mesosphere, thermosphere, you can go for option as ozone is present in the, obviously that is 10 to 50 kilometers, that is nothing but stratosphere. So we can go for option as stratosphere for this question here. Okay, now coming to some more detailed discussion about each and every atmospheric region. Now let's move to stratosphere. In the stratosphere, you will have ozone layer, a solid thick ozone layer right from 35th kilometer to 50th kilometer. 35th to 50th kilometer, that solid thick layer which is produced by nature because of absorbing sunlight. Because of absorbing sunlight, this 35th kilometer onwards to 50th kilometers, a thick layer is produced, that is called ozone layer. There the oxygen absorbs UV light, sunlight, then converts into ozone by nature. That ozone layer is there in the stratosphere. It is protecting life by stopping ultraviolet radiations which are coming from the sun. That is what the stratosphere helps us. Okay, then coming to 50 to 90th kilometer, mesosphere. In the mesosphere, mainly sound waves do not propagate, and its height is also 50 to 90 kilometers, and it is having gases as N2 and its ionic gas O2 plus. And here, because of more high temperature over here, as more height is altitudes are going up, slowly the sound waves do not propagate here in this particularly mesosphere. Then coming to the last one, 90 to 500 kilometer, thermosphere, where you can observe the very high temperature regions. Here, because of very high temperatures, gases will be ionized. As you can see, O2 becomes O2 plus, nitric oxide gas is becoming NO plus, and the ionization of gases occurs because of this high temperatures, higher altitudes in the thermosphere. So we can go from 90 to 500 kilometers as this one, and there it is releasing the atmospheric polluting gases like nitrogen dioxide and all. Because of this reason, Russians banned the usage of supersonic jets in this particular region which are traveling. So this is all we'll discuss in the coming topics. So we'll have a detailed discussion. This is only the introduction part for the topic, and let me discuss some more related terminology for the topic. If you understand the terminology, we can go into the details of the topic. Now let us see definitions of certain terms like pollutant, contaminant, receptor, sink, speciation, threshold limit value, dissolved oxygen, chemical oxygen demand, biochemical oxygen demand, etc. Technical terms we will discuss now in this topic. After that, we will go into the details of the topic and we will do some related objective questions. Let's see what is meant by those terminology and related questions here. The important terminology is now pollutant. This is pollutant. What is meant by pollutant? Already I have discussed about pollutant, terminology names I have discussed. So let us see now about pollutant definition and all. Meaning, a substance present in the nature in greater amounts than natural abundance due to human activity. It is there in the nature, by nature itself it is there in the environment, but because of human activity it has been increasing, and which is causing harmful effect on the living organisms and mankind. That is called pollutant. So pollutant is a substance present by nature in the nature itself, and due to human activity natural abundance has been increasing day by day and causing harmful and adverse effect on the living organisms and even mankind. That is what the word pollutant means. Coming to contaminant. Contaminant is not there in the nature. It is being introduced only by human activity. So a material which does not occur in the nature, but it is introduced by human activity only in the environment and causes adverse effects in the environment. Its constituents causes environmental effects. Best example for contaminant is methyl isocyanate, MIC. Second one is contaminant, and the example for this is methyl isocyanate, MIC. You know about pollutant examples. What are all pollutants? You know, carbon dioxide, nitrogen oxides, okay, sulfur dioxide. These are all examples comes under pollutant. And coming to contaminant examples, methyl isocyanate, MIC, methyl isocyanate. It is not there in the nature. It is being introduced only by human activity and causes adverse effects to the environment. This is another term, contaminant. Coming to next term, receptor. When you stop at the traffic signals, our eyes starts burning. The eye starts burning because it is receiving some gases releasing from automobile exhaust fumes. The medium which is affected by the pollutant is called receptor. The eyes are affected. The human body totally is affected. When you stop at the traffic signal, immediately our eyes starts burning because of the exhaust fumes. There the receptor is eyes. If you stay for a long time, totally we may get headache, we may get so many other health problems because of the receiving gases here. So the receptor is human body. So the medium which is affected by the pollutant is called receptor. And example, man or human beings, okay, mainly affected. So we are all receivers. So this receptor is human eyes. Then if you leave that space after some time, we can feel again relaxed because the receiving gas has been exhausted over there. So like that we can understand what is actually the meaning of the receptor. Coming to the next word, sink. Sink is the medium which retains and interacts. Receptor is only affected. Sink is retaining the pollutant and also interacting for a long time. So the medium which is retaining and interacting with the long-lived pollutant is called a sink. Example for sink is sea water, ocean water. Ocean water is a sink for carbon dioxide, sulfur dioxide. Soil microorganism is sink for carbon monoxide. Soil microorganism is a sink for carbon monoxide. A marble wall is a sink for acid rains. That is the reason the beauty of the Taj Mahal is being decreasing day by day, because it is absorbing acid rains on the marble structure. So sink, actually it is a medium which is long time reacting with the pollutant and interacting with it and causing adverse effect. Next, coming to speciations. Speciations. Coming to the speciations, the meaning of this is the detection of different chemical forms of organic, inorganic or organometallic, you can call, compounds present in the environment causing pollutant is called speciation. So I repeat, the detection of different chemical forms of inorganic or organic or organometallic compounds present in the environment causing pollution is called speciation. That is a correct meaning of the word speciation. So many particulate speciations there are, so many microscopic pollutants are releasing into the atmosphere from the so many sources, and they are all causing releasing as coming out as a species or speciations. If at all we see one or two questions on this, the medium which is affected by the pollutant is called, if somebody asks you which medium is affected by pollutant, okay, what is the answer for this? Which medium is being affected? Answer is receptor. Now next question you can ask, the medium which retains and interacts with the long lived pollutants, retains and interacts means which is retaining on it and interacting with long time, it's called nothing but sink. Already I have discussed about this, that is called to be a sink. Long time it is keeping pollutant on it and interacting with it. After speciation, threshold limit value, TLV, threshold limit value. What does it mean? It is the permissible level of toxic pollutant in the atmosphere, present in the atmosphere, to which a healthy industrial worker is exposed during an 8 hours a day, that is his shift time, without any harmful effect is called TLV, threshold limit value. So if the threshold limit value is more, it is safe. If the TLV value is low, it is dangerous to work for the workers in the lower levels. If the factory is having TLV value 500, another factory is having TLV value only 0.2, so it is dangerous to work in 0.2 rather than 500. Therefore lower TLV value dangerous, more TLV is a safer one. Like that we can understand the concept here. Coming to another terminology, chemical oxygen demand, COD. COD stands for chemical oxygen demand. It is the amount of oxygen required or demanded, okay, by the organic matter present in the water for their oxidation. It is called chemical oxygen demand. The amount of oxygen required to oxidize organic matter present in the polluted water is called chemical oxygen demand, COD. If the water is demanding more and more amount of oxygen, COD value is more. If more demand is there, means more chemicals are present, more oxidation is needed, therefore more is the COD value. You can see COD is determined by laboratory methods by oxidizing the organic matter with 50% acidified potassium dichromate solution. 50% sulfuric acid plus potassium dichromate together is added. This 50% acidified potassium dichromate solution is added to organic matter containing water. It is being subjected for oxidation. Okay, and by this way we can calculate chemical oxygen demand value. It is an important parameter for the determination of quality of the water. If the COD value is more, obviously organic matter is more, the demand is more, then water is more polluted. Like this we can understand higher COD indicates water pollution. Coming to biochemical oxygen demand, BOD, biochemical oxygen demand. It is also demand for the oxygen by microorganisms present in the water. The amount of oxygen used by suitable microorganisms present in the water during the 5 days span at 20 degrees Celsius is called biochemical oxygen demand. If the water is demanding more and more oxygen for 5 days time at 20 degrees Celsius, means that water body is having more microorganisms. More is the microorganisms, more is BOD. So higher value of the BOD indicates water pollution. Higher value of COD indicates water pollution. For pure water, if you calculate BOD value, it is about 1 part per million, 1 ppm. And BOD for the municipal seepage water is around 100 to 4000 parts per millions, municipal seepage water. Then, and BOD greater than 17 parts per million usually indicates high pollution and it is harmful water, not safe water. So with this we can understand higher value of COD, higher value of BOD indicates water pollution. Lower value of COD, lower value of BOD indicates safe water. COD is chemical oxygen demand for the oxygen by organic matter. BOD is a demand for oxygen by microorganisms. So in both the ways, if the demand is more is water pollution. By this way, you can understand these two concepts. Coming to few conceptual questions I'll ask you on this. COD is determined by, if the question is asked, how do you determine COD? Already I've discussed. So they may be giving you 4 options here. I'm asking you, how do you detect or determine COD in the laboratory methods? If they give you 4 answers over here, directly we can go for answer as acidified potassium dichromate solution, 50% sulfuric acid and plus K2Cr2O7. Together we can use for the determination of chemical oxygen demand, okay, in the water. Like this, they can ask you, okay, a related question to BOD in this way. There are, okay, for pure water, what is the BOD value? It's about, BOD value is about for pure water. Already I've just now discussed. Okay, 1 ppm, 100 ppm, 4000 ppm, 17 ppm. So for pure water, what could be the BOD value? It is obviously, you can answer for 1 ppm. For pure water, the BOD is 1 ppm. Like this, we can just think and we can answer the basic questions on this modules. Okay, so this is BOD. Coming to one more, dissolved oxygen, DO. DO is it's a demand for the oxygen by the aquatic life in the water. If the aquatic life is demanding more and more oxygen for their survival, that water is said to be harmful, or I mean to say it's a polluted water. If the dissolved oxygen optimum level is 4 to 6 grams per liter, in 1 liter water there should be 4 to 6 milligrams of dissolved oxygen must be there. It is a safer one and it is giving a good healthy aquatic life, so that the aquatic life, fish and plants and all, they can survive easily in the dissolved oxygen levels are to certain extent. If the DO value is very low, let's assume that water is polluted water and it is said to be harmful water, it is not fit for a survival of the aquatic life. That is a dangerous sign here. So we can understand that higher COD, higher BOD are dangerous, causing water pollution. Higher DOD, if the DO value is high, it is safe. Whereas lower DO value is harmful. Lower DO is harmful. Here higher COD, higher BOD harmful, but lower COD, lower BOD are safe. Like this, we can discuss some terminology in this topic. Okay, thank you.